In this video, we are going to study exponential smoothing with Brown's simple method in Python using Spyder ID. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Also, as you can see at the bottom of the screen, it's important to remember that when doing time series analysis and forecasting, past performance does not guarantee future results. Okay, so let's go into Spyder IDE. So the first step within the video is we need to import the corresponding packages. Therefore, we comment this as step 1, packages. And we are going to import pandas as PD. We're importing pandas for data frames. Then we're going to import statsModels.api as SM. We're importing that feature from statsModels for data downloading. Then we're going to import statsModels.tsa.holdWinters as ETS. We're importing that feature from statsModels for exponential smoothing method. And last, we're going to import matplotlib.pyplot as PLT. And we're importing that feature from matplotlib for exponential smoothing method chart. To run these code lines, we go ahead, select them, and then we can either click the Run Selection button or we can press F9 on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named mData, that's model data underscore obj for object, which is equal to, and here we'll be using sm feature from statsModels.datasets.get underscore r dataset. And we open parentheses. First parameter, which is a data name, equals to, within quotations, air passengers, comma, and at the following row we have package, equals to, and within quotations, datasets, comma, at the following row, cache equals to true. So what we're doing here is the following. We're downloading air passengers data from our package datasets. And with cache equals to true means that once we download the data, it saves it locally, so we don't need to go and download it again every time we run the code. Notice that this will download data and documentation within mData underscore obj object. Therefore, we're going to create a new object named mData with only the data, therefore equals to mData underscore obj, and we're going to get its .data attribute. And the next step is we're going to convert this data into a pandas data frame. So we override it with mData equals to, and here we're using PD or pandas.data frame, and we open parentheses, data equals to mData object, and we're going to select its value column. And then we're going to set its index with set underscore index. And here the parameter, which is going to be at the following row with PD or pandas.date underscore range. And within it we have the following, which is start equals to, and within quotations, 1949, comma, end equals to, within quotations, 1961, comma, FREQ or frequency equals to M, because this is monthly frequency. And last, we want to print the documentation of this data, and we do so with print, and from mData underscore obj, we're going to get .2 underscores doc 2 underscores attribute. So to run these code lines, we go ahead, select them, and then we're going to press F9 on the keyboard directly. And right here within the console, we can see the documentation, so we're going to scroll up. So as mentioned here, we have monthly air passenger numbers from 1949 to 1960, these numbers in thousands. And if we go into the variable explorer, we can see the two objects being created. mData underscore obj, which is the object with data and documentation, and mData, which is the data frame with only the data. Therefore, if we double click on any of these cells, we can see the data. And as mentioned here, we have the data, the index with the corresponding date, and this value, which is the monthly airline passenger numbers in thousands. So the following step is we are going to do ranges delimiting. And we're going to create two ranges, a training range for model fitting and a testing range for model forecasting. So let's begin with the training range. So we are going to create an object named tData, which is equal to, and here we'll be using mData object, and we're going to select from the beginning of the time series all the way into the end of 1958. Therefore, 1958-12-31st. So it's the 31st of December of 1958. And then we have fData equals to, and again, using mData object. In this case, we're going to select from the beginning of 1959, 1959-01-01. So we have January 1st of 1959 all the way to the end of the time series. So the training range is the first 10 years of data from 1949 to 1958, and the testing range is the last 2 years of data, 1959 and 1960. To run these code lines, we go ahead, select them, and then we press F9 on the keyboard. And now that we have the data ready, we can continue with step number 3, which is exponential smoothing. And in this video, we are going to study Brown simple exponential smoothing. And for this, we're going to create an object named tBrown because we're going to do first the model fitting. And as mentioned previously, this is done within the training range. Therefore, it is equal to, and here we're using ETS feature from statsModels.exponential smoothing function, and within it the following parameters. ENDOG with the data, therefore equals to tData because we're doing this model fitting within the training range, comma, trend equals to none, comma, at the following row we have damped underscore trend equals to false, comma, seasonal equals to none. So this 3 parameters, trend equals to none, dampened trend equals to false, and seasonal equals to none because we're doing Brown simple exponential smoothing method. And last we have at the following row the initialization method. Equals to, and at the following row within quotations we have estimated, and we go ahead and fit this corresponding Brown simple exponential smoothing method. So this initialization method is the initial values estimation method, and in this case, because we have estimated, we are going to estimate those initial values together with Brown simple exponential smoothing method parameters. Notice that the parameters included here within exponential smoothing function together with ranges delimiting were only included as educational examples which can be modified according to your needs. And after doing this model fitting, we're going to continue with the model forecasting. So we're going to create an object named fBrown, and this is equal to, and here we'll be using tBrown object, the one we fitted above, and we're going to use its forecast function. And within it we have the parameter steps equals to, and here we have len, which is the length of the testing range. So an important observation regarding this forecast is that this steps is the number of steps ahead forecast. The reason for this is that we're doing this forecast for the full testing range in advance without using any testing range data. And the following step is we are going to convert this also into a pandas data frame. So we overwrite fBrown equals to, and here we'll be using pd_pandas.data frame, and within it we have as data fBrown, and we're going to do its set underscore index, and we're going to copy the index from the testing range. So we have fdata and dot index. So to run this code lines, we go ahead, select them, and then we're going to press F9 on the keyboard directly. And the following step is we want to visualize this within its corresponding chart. And for this, we use PLT, which is matplotlib.figure, open and close parentheses, and we're going to add to this figure the following: plt.plot, and within it first, t data, that's the training range data with its label, equals to, and within quotations, t data. Then we're going to do plt.plot again, so we're going to add fbrown, which is the Brown simple exponential smoothing method forecast, as mentioned previously, done for the full testing range in advance without using any testing range data, with its label equals to fbrown. Then plt.plot, and we're going to add fdata. This is the testing range actual data, so that we can compare it with the forecast, with its label equals to fdata. And in this case, we are going to modify its line style, which is going to be equal to dash type of line style. And then we're going to add plt.legend. This is going to be located at the upper left. Then plt.title, which is going to be simple exponential smoothing. Then plt.y label, that's the vertical axis label, which is going to be air passengers. Then plt.x label, that's the horizontal axis label, as year. And last we have plt.show, so that we can visualize this chart. So to run these code lines, we go ahead, select them, and we press F9 on the keyboard directly. And with this, we see the chart right here within the console. If we scroll up, and if we go into the plots tab within Spyder, we can see the corresponding chart as well. So we see its title, which is simple exponential smoothing. On the vertical axis, we have air passengers. On the horizontal one, we have year. Then the solid blue line, that's the training range data. Then we have the solid orange line, that's Brown simple exponential smoothing method forecast, which was done for the full testing range in advance without using any testing range data. And last, we have the dash green line, which is the testing range actual data. Okay, so with this, we finish with the code file, so we can go ahead and save it. And with this, we also finish with this video. Thank you for watching.